Hi guys, myself V. Gopinath, working as assistant professor in the Department of Computer Science and Engineering. Today we are going to see the topic of distribution model, how the distribution has been done in big data analytics. So let us move into the topic, distribution model. As the name suggests, that distribution of models, that means huge number of data has to be distributed from single server into multiple server. It is called distribution of models. The primary driver of interest in NoSQL has been its ability to run the database on a large cluster. So the basic interest of NoSQL has to be to run the database in a large cluster. As the data increases, as the size of the data increases, it becomes more difficult and expensive to scale up. So that huge data is increases. When data is getting increases and increases every hour or every minute, then it will be very difficult to manage the entire server. So in order to buy, then for that we need to buy a bigger server or to run the database, so etc. So the more appealing option is to scale out. That is to run the database on a different cluster of server. So in order to buy a big server, we can able to run this database on a cluster of servers rather than single server. So the aggregate orientation, this fits well with the scaling out. I mean scaling out in the sense they run the database on the cluster of servers, because the aggregate is natural unit to use for distributions. This is about distribution model. The distribution model, the first one is single server. Single server, the first and simplest distribution option is the one that we can find out is that no distribution at all. There is no sharing is needed. That is the first often recommend. And the second one is to, in order to run the database on a single machine that handles both all the reads and writes. This file has to be read and write. It has to be done on the single machine. Okay. And the third one, we prefer this option. We need to read operation as well and both are the write operation as well. For this option, because it eliminates all the complexity that the other option introduces. And also it is very easy for operations, the peoples to manage, and easy for the developers to reason about. And next topic is sharding. Sharding, we know that sharding is a technique that is used in the big data to distribute massive data set. That means the data set is very large that has to be distributed in a massive data set across multiple nodes, not on the single node, across multiple nodes or server in order to improve the scalability and also the performance of the data and a fault tolerance. So look at the diagrams here. Here the sharding, it puts the data on the separate node. So that is, it has a definition suggests that it puts data on the different nodes. I mean different nodes and different servers in order to improve the scalability and also the fault tolerance. And the example also suggests that the shard can, the sharding can done both reads and writes on its own data. So it enables that huge volume of data handle. I mean it handles huge volume of data very efficiently and also in a distributed database. You can easily see in that example also. In sharding, we have two components under that. We have master-slave application and peer-to-peer applications. Let us explain you what is meant by master-slave applications and with one simple diagrams. Here is the master-slave. As the name suggests that master, it has only one master and it has number of slaves around that. Master, that is the working of master. If you can ask, it can done write operation. That is, if any update we need to done in the datas or in the database, we need to done via only in the masters. So here all the updates has to be done only in the master. So what is the work of slave? Slave can read, but it cannot perform any write operations. So the slaves around with the masters can be reads alone. So it can be read any kind of data. It can be read done from master or it can be read it from the slaves. But the changes can be done only with the help of masters. If suppose master node is fails, what happens here? The drawback is only if master node fails, that has to be waited. Any one of the slaves gets activated by the um, the slaves become master. So till the time that master has to be wait. Otherwise, that master failed master should be rectified. Until that master has to be waited. No right operation has to be done till the master recover. So here the data is replicated from master to slaves. The master service all the write operation as I said earlier, and the read can done only from so read is not a daily problem. It can be done either with the master or with the slaves. And next one is peer-to-peer replications. Here the peer-to-peer replication, as the name suggests, that here there is no master and all. Here we have only peer concept. The peer, all the peers are interconnected. So any peer can be acted as a master. Before that we can say if the master fails, then we have to need to wait that till the master recovers. But here we can say that any node of the any peer node can act as a master, can done the write operations. So master slave replication helps with read scalability but does not help with the write scalability. So it provides resilience against failure of slaves, whereas in the peer-to-peer, it does not have any masters. So all the replicas have equal weightage and they all can accept the write operation and also the read operation. Let us look at these diagrams. So all the nodes, that is all the nodes are equal here. All the nodes can read the data, all the nodes can update the data, all the nodes can write the data. Here there is no issues. Suppose any one of the node fails, then the other node could have the recovered one. So all the dates are replicated one node to another. So there is no issue of data loss. So that's it about the peer-to-peer. And final one, combining the sharding and replication. We can know that sharding is nothing but the distribution of nodes among the different across nodes. The different nodes and servers. Whereas replication is all about copying of one data from the another, copying of one data from one node to the another. That is called replication. So it depends upon your configuration and our needs. We can choose the it may be sharding technique or maybe a replications technique. So that's all about this distribution model. We'll look into the another video with some new topics. Thank you.